Not going to be as interesting as before, but I'll try to keep this as short as possible and try to entertain you guys. So my presentation is going to be on coding and basically what you can do with coding, the past of coding, the future of coding, what you can do in general. Now I'm not going to give you guys a coding lesson because I think that's really boring, but I'll just go over how that has influenced our lives. Let's go on the next slide. So this is my table of contents. I'll start by talking briefly about what coding is exactly, how coding is right now, what coding is for the future, and just some coding languages in general. Next slide, please. So what is coding? Does anyone have any ideas about what coding is? Scott?
Python.
Python, that's an animal. Yes, but it is also a coding language. Does anyone else have any ideas about what coding is? Scratch. That's how you can get hurt. Okay, but it is also part of coding. But Richard, if you can go on to the next slide, please. So basically, the definition of coding, which I actually got off of ChatGPT, is that it creates instructions for computers using a programming language. So coding, also known as programming, as I said before, involves creating instructions for computers to follow. It's how we communicate with machines, essentially. And so by communicating with them, we can have them perform specific tasks with languages, like Scott mentioned, Python, JavaScript, and C++. We can use coding to ask them to perform these tasks, which the computer processes, the computer takes in the language, and that results often in apps, functioning web pages, and software in general. Richard, next slide, please. So how does coding work? For example, I gave examples of Python, JavaScript, and C++. As Olivia said, Scratch also counts. So what actually happens is you put it in the computer, but the computer can't read. So most of the time, the computer can't read the code automatically. So what actually happens with a lot of coding languages is it turns it, the original input, which is Python, JavaScript, and C++, sorry, it turns it into a language it can understand, which is often in binary code or something else like that. And so what the outcome is, as I mentioned before, are apps, website, and softwares. Richard, next slide, please. So let's look at coding right now, and let's look at the history of coding. Next slide. So in the early days, coding was very, very simple. We had simple machine code and assembly language, so very, very basic. It wasn't even coding at all. But over time, more higher level languages like Fortran, COBOL, and C emerged in the 1950s to the 1970s. I know a lot of people here probably have used C in their lives, and it's still a very popular language today. So now we've moved on to more modern languages. Now the most popular ones include Python, Java, and JavaScript. However, the focus right now in coding is not to develop more languages. It's actually to make these languages faster for processing, so the computer, and make it more reliable so the computer can actually do and complete tasks faster. Next slide, please. So what is coding used for today? We can use coding for a lot of things. So for example, we can use it for web development. The most common examples you see today. For example, this slideshow. This slideshow, while I did do it, the application that is powering this slideshow was made by coding. Google, something you use every day, was done by coding. Every single web page used probably on Instagram Reels right now, that was also used for coding. It can also be used for data science. So every single day, I'm pretty sure, how many of you guys have ChatGPT or use ChatGPT? A lot, right? So a lot of ChatGPT is actually machine learning and deep learning. And that also comes with analyzing large data sets. And that's basically what powers the AI. And finally, we have automations. For example, manufacturing cars, manufacturing things like that. Coding actually helps a lot with that because it can automate machines to do things without human intervention. So next slide, please. So coding for the future. So what can we see? What are some implements of coding that we can do in the future? What are some uses? Next slide. Richard, next slide. Okay, so first of all, we already have AI-assisted coding. So for example, for all of my school projects which involve coding, I've basically ChatGPT'd every single one of them, and no one can tell. So the increasing use of AI tools to write and optimize code will be something that will be implemented in the future. And right now, a lot of things, for example, making this PowerPoint. I didn't code this PowerPoint. This PowerPoint isn't coded. I never truly made it. How did I make it? I made it through PowerPoint. Now what is PowerPoint? PowerPoint's an example of low-code or no-code programming, which is you put your, it allows the user to make something, make a web page or make a PowerPoint, make a video or something like that, without actually coding. It allows you to do it by just entering text boxes, making transitions. Things like that are already pre-programmed into the software. And we can also have quantum computing. Now this thing is still at its early stages right now, but new programming paradigms for quantum computers can make things a lot faster. So supercomputers, like the ones NASA, Google have, make them a lot faster. And then finally, increased automation, as I mentioned before, it will allow automation, so factories, everything else to go a lot quicker. Next slide, please. So what will the future entail for all of you if you're curious or you want to go into coding? So coding skills may be in the future. It is already right now. It may be essential as literacy. So I take a lot of coding courses in school. Many of them are not mandatory, but when I was younger, a lot of things like Scratch, a lot of things like programming Lego, those were required assignments in school. So coding may become as essential as reading a book is. And integration applications. So for example, we can integrate coding into things like biology, nanotechnology, and other fields. We have ethical considerations. As coding becomes more and more used within our lives, people are going to have ethical concerns. And finally, global collaboration. As the internet continues to expand every single day, coding will have, many people will find it easier to collaborate online. And coding will become more global, and we'll see bigger project collaborations in the future. Next slide, please. So this is basically a roadmap of what you want to do in coding. So if you ever want to pursue a career in coding, coding offers a wide range of career opportunities. Now this includes software development, data science, AI, cybersecurity, a lot of things like that. And so to pursue these careers, you can learn from multiple pathways. So those include online courses, university courses, or coding boot camps. So as you start, it's important to build a portfolio. It's important to build what you do. You want to start with smaller projects, and you want to contribute to open source projects that are visible to everybody in the community. You also want to start on GitHub, which is also a platform that will allow you to spread your message. Finally, a lot of people think networking isn't important in coding. It really is. Right now, if you look at big tech companies like Google, let's say Tesla, companies like that, they're rarely built by one person. And so networking and working with other coders, other programmers is extremely important towards coding. Next slide, please, Richard. So I said I wasn't going to give you a coding lesson, and I'm not. But I'm just going to give you guys the basics of coding, because this presentation has to be 10 minutes long. I don't think it is right now. So first thing you need to do is choose a language. So as a lot of people mentioned before, C++, Python, those are really, really good choices for beginner coders, because they're simple, they're easy to use, and you really can't go wrong with them. Second thing, you need to learn the basics, things like syntax, things like how you get the computer to print something. These easy things and basics are extremely important towards knowing how to code. And finally, you need to set up your environment. So you can't just code on a web page. There's no way you can just open up a Google tab and suddenly decide to code. You need to install actual code editors like Visual Studio Code or other programs to actually get started with coding. Richard, next slide, please. So you also need to write simple programs. So how I started in coding was I was extremely curious in how to make a game. I used to play a lot of games when I was younger. I was really curious, how did people make these games? And so what I did was I began with small projects like a calculator, or like I programmed Flappy Bird when I was younger. And so you also need to debug your code a lot, and this comes with, this is one of the most common things in coding. And so you need to regularly fix your code and any errors that arise. So one problem I find with ChatGPT when I use it for school assignments is that it has a lot of errors sometimes in the code. So debugging is extremely important. Even if you don't know how to code and you use ChatGPT, you need to know how to debug. Next, you need to know how to, you've got to practice your skills. So either if you want to be a real coder, you need to program more, do more of these small projects, things that interest you. If you're not a real coder, you need to learn how to use ChatGPT better. And so finally, you need to use resources. There's things like online tutorials, coding communities, and documentations. It's all online. Things like Stack Overflow. Those are the things that will help you get further along in this coding world. So Richard, next slide please. So yeah, thank you everyone. Do you guys have any questions? I assume not, because I was pretty thorough. Okay. Oh, Richard, what's your question?